Hi everybody! In this lecture, I will give you the basic intuition behind solving a given system of linear equations. To do so, I will start with the very simple case with a 2 by 2 equation system where we have two equations and two unknowns. And following that, I will try to answer basic questions such as what does it mean for us to solve a given system of linear equations? In other words, what does a solution set mean? And how many alternative possible ways are there for a solution set of a given system? And can we interpret it from a geometric point of view or explain it in terms of geometry? And I will talk about all of these concepts related to solving this system of linear equations. Well, why I want to start with such a simple case? Because when we start with the simplest case possible for solving a system of equation, then we can generalize our idea in terms of finding the solution and the geometric interpretation of solutions and the possible alternative ways to more generalized concepts or to more generalized forms of equation systems where we will have m equations and n unknowns, what we call m by n system. Okay, so saying that, let's start with a very simple case. Suppose this is our equation where 3x is equal to 9. You see, this is very simple, right? Because what we have here is just one unknown variable. That's it. This is the x is the only unknown variable in this equation. And what we are trying to find is the value of x that satisfies this simple equation. And as we all know from our college algebra course, what we need to do is to find the value of x, we divide both sides of the equation by the coefficient of x, which is 3 in this case, and find the value of x that satisfies this equation. And as we can see, simply x is equal to 3. It's simple as that. In other words, when we have only one unknown variable, which is x, in this equation, we can simply use our algebra knowledge to solve such an equation and find the value of x. And what is its geometric meaning is that it is just a real value, right? Because it is the only unknown that we are trying to find. Now, let's generalize our idea to a more advanced system of equation. And what I mean is that if we have, say, two equations and two unknowns, suppose here's the equation 1, x1 plus x2 is equal to 4. Let this equation be our first equation, say first equation 1, and the second equation, let the second equation be 2x1 minus x2 is equal to 5. Now, what's the difference of this system of equations from the one written on the above? We had one unknown variable in the above equation where 3x is equal to 9, but now we have two unknown variables, right? We have x1 and we have x2, and plus we have now two different equations. So how are we going to solve this equation? Okay, so again, based upon our basic knowledge from college algebra, what we can do is that we will try to eliminate one of these unknown variables, and then after reducing the number of unknown variables to 1, we solve the remaining equation for that unknown variable. Okay, so we can add these equations term by term on both sides of the equality. In other words, we apply an element-wise addition on both sides of equality, and as we might see, x2's are cancelled out, and what we have is x1 plus 2x1 is equal to 3x1, right, equal to 4 plus 5, 9. And now what we have? Just a moment ago, just a few seconds ago, we had two equations and two unknowns. But now we have one equation and one unknown, right? Which is x1 in this case. So it is as simple as solving the equation in the above example, right? What we need to do is just divide both sides by 3 and find the value of x1, one of the unknown variables in this system. Here's the x1. x1 is equal to 3. 9 divided by 3, right? And the quotient is 3. So we find one of the unknown variables. Then how can we find the value of x2? After finding one of the unknown variables, we have only two unknown variables. And if we know one of them, in other words, if we know the value of one of them, then it is simple to find the other one. What we need to do is we simply plug the value of x1 in one of these equations, either in the first one or in the second one, because if x1 is satisfying all of these equations, and x2 should do the same thing, right? Doesn't matter in which equation we plug the value of x1. Suppose we put it on the one above, in other words, in the first equation. Plug it, 3 plus x2 is equal to 4, and x2 is what? x2 is, right? We move it to the right hand side of the equality. It becomes minus 3, right? So you see, x2 is 1. And what we have found here is that we were looking for a two-tuple where this two-tuple is nothing but x1 and x2 ordered pair, right? And we have found the value. So x1 is 3 and x2 is 1. So this two-tuple is 3 and 1. Now what we found? We found the solution to this system of linear equations, right? We have two equations and two unknowns, where the unknowns are x1 and x2. And now, by using elementary arithmetic operations, we just reached to a solution, right? Which is 3, 1, and x1 is 3. And what it means is that we actually just have found the solution to this 2 by 2 system. And why is that 2 by 2? Because we say this is a 2 by 2 system. The first two on the left hand side represents the number of equations, because we have two equations, and the right hand side 2 represents the number of unknown variables, where in this case, in our example, we have two unknown variables, namely x1 and x2, right? And the solution means that we found a point, which is 3, 1 in this example, that satisfies both equations in this system simultaneously. In other words, when we plug the value 3, 1 in either of the equations, all of the equations would be satisfied. So, finding a solution to a given system of linear equations, in short, means that finding a tuple, right? Depending on the number of variables, unknown variables. In this case, we have 2 variables, unknown variables, and it's a 2 tuple. If we had 3 variables, unknown variables, it would be a 3 tuple, and n variables would be an n tuple, right? So when we plug this value, this would satisfy both equations. So the definition of solution set means of course for a given system of linear equations again, is that and any tuple that satisfies both equations at the same time. Okay, so we understand what a solution to a given system is. Now, what does it mean? So, can we interpret it from a geometric point of view? Let's see what can we do about that. And the answer is yes, because I start with the simple case where we have a 2 by 2 system in order to not only solve what a solution means, but also express it from a geometric point of view. And what I mean is this. Let's show the result, or what we have found, on the coordinate system, on the plane, where x values, or the x-axis, represents the horizontal axis, and y values is represented by the y-axis, this vertical axis. And in our case, we consider the x1 values as the x-axis and x2 values as the y-axis. So each of them is a line on the coordinate system, right? Because it's just like x plus y is equal to 4. The same thing, just the labeling is different. So how would we draw these lines? If we take the value x2 is equal to 0, which means y is equal to 0, then it intersects the x-axis. The line intersects the x-axis, and which is 4 in our case. And if we take x1 is equal to 0, then y is 4 again. In other words, x2, right? So if you draw this line, this is something like that, right? How about the second one? The same procedure will be applied on it as well. If we take the value x2 is equal to 0, then x1 is 5 over 2, which is somewhere around here. 5 over 2, right? 2.5. And if we take the value x1 is equal to 0, then it intersects the y-axis in the negative direction, and in this case this is minus 5, right? And now we can draw the line, right? Here's the line, this line for the second equation, and this line is for the first equation. And what I'm trying to do here is that actually what I've been trying to explain to you. If you might probably have noticed that there's an intersection point right over here. Line segments intersect at this point, as I pointed in bold black, you see? So what is this? This is actually the point we've just found. We assert that this is the solution to our system, right? Because if the point satisfies both equations, then it must be the intersection point. In other words, the x value of this point should be 3, while the y value of this point should be 1. And therefore, finding the solution to a 2 by 2 system means that actually finding the intersection or intersecting points on the coordinate system of the lines. Okay, so now let's recap what we have learned so far. We now know what a solution is, and solution or solution set, we can say, a solution or a solution set to a given system of linear equation is nothing but an n tuple. In our case, in 2 by 2 case, it is just a 2 tuple that satisfies both equations simultaneously. And geometrically, what it represents on the coordinate system is that the intersecting point or points of the lines, in other words, our solution are nothing but the intersecting point of the lines. And another thing to notice here, before proceeding to the other case of the solution, is that you see we have only one solution, right? So this line intersects at only one point, at one single point, and this is the unique case. In other words, solution to a given system can be unique. This is one thing also we can conclude from this simple example. Okay, let's continue our reasoning with another alternative for the solution. Right, let's erase this and go with the second example, and meaning that the second alternative for the solution. Now, suppose we have such an equation. Equation 1, a plus b is equal to 3, and a plus b is equal to 4. Okay, now this is, let's see, this is the second system. Okay, this is equation number 1 and this is equation number 2. Okay, let's see what I'm trying to say about this system. Again, we have a 2 by 2 system, and how do we understand that? Because we have two equations and we have two unknown variables, where in this example our unknown variables are a and b's. Well, before proceeding the result, or what we can conclude from this example or this type of equation, I would like to also point out one more thing. We call, as you might notice, we call that it's a linear system. Why? Because our unknown variables have the order 1, right? They are not explicitly there, but we know they are there, right? These are a prime, a to the power of 1, and these are nothing but means a and b, right? Any power of any number to the 1 is the same. A to the power 1 is a, right? 2 to the power 1 is a, 2. Alright, let's erase this to avoid any confusion. Okay, let's get back to our point. So, but by the way, when cannot be non-linear is the case where it is non-linear. In other words, if it were like a squared plus b cubed, then it's a non-linear equation, or maybe a to the power of 1/2 or something like that, different from 1. If the values of power of these unknown variables are different than 1, then this is not a linear equation. This would be a non-linear one. Okay, if it's not a linear, it's a non-linear, but it's not our case. This is out of scope of our course. Okay, because we will be trying to solve a linear system of equations. Okay. All right, let's get back to our point again. Now, again, we have actually two unknown variables, which means we can draw these lines on the coordinate system, right? So let's do that and see what we get. In the first example, as you remember, we have the unique solution case, right? Because two lines intersected at only one single point, and which means that we have only one solution. In other words, only one single point that satisfies both equations concurrently. But let's see what we got in this case. And how we draw it again? If we take the value b is equal to 0, well, by the way, say it x and y as always. And suppose a represents the values on x-axis and b represent the y values, okay? So if we take b is equal to 0, then it intersects x, right? Which is 3. And if you take a is equal to 0, then b is 3, and the equation number 1 is nothing but this line. Okay, and equation number 2, in the same manner, if we take values a and b is respectively equal to 0, we got another line, right? Something like this, where it passes point 4 on the x-axis and 4 again on the y-axis. But then what we have here, this is another case, right? So actually a solution means a point that satisfies both equations. In other words, when we plug that value in equations, in each equation, that it must satisfy all of these equations at the same time. But based upon what we see here, there is no such a point, right? This line segments, these lines are parallel with each other. They have the same slope, but they don't intersect at any point. Well, this is the second case that we can run into while we try to solve a system of linear equations. And the thing is, now our solution set is what? Our solution set is nothing but empty set. There is no solution. There is no point that satisfies both equations at the same time, because line, as you see, based upon my drawing, there is no point these lines intersect. So this is another case. So now we have two alternative possible ways for the solution of a given system of linear equations. The first one is the unique solution case, where we have only one single point that satisfies both equations. We have the case where we have no solution. In other words, our solution set is empty set. Okay? Now, let's see another one. Now, let's raise this to avoid any confusion and take a look at the third case. What is third case? Let's see. Okay, now suppose our equation is long tail, right? Let's erase it a little bit. Let's get back to my equation. A plus b is equal to 2, right? And 2a plus 2b, let's say, is equal to 4. Okay. First of all, from a mathematical point of view, look at this equation that I've just written on the whiteboard. Let's say number them or label them with numbers from top to bottom in the increasing order from 1 to 2. Well, if you notice, if I multiply both sides by 2 in the first equation, I reach to the second equation. Or if I divide the second equation by 2 on both sides of the equality, I get the first equation. And what it means from a geometric perspective. Let's see what it means. Okay. Again, A represents the values on x-axis and B represents values in y-axis. And the first line, so would be what? The first line would be this line passing through, intersecting x-axis at 2 and intersecting y-axis at 2 again. And how about the second equation? Well, the thing is that they are the same line, right? Because if you cancel out these 2's, in other words, if I parenthesize, they have common factor, as you may notice. I can parenthesize because 2 is the common factor on the left hand side of the equation as well as on the right hand side. You see, if I parenthesize 2 in parentheses a plus b is equal to 4, and then dividing both sides by 2, what we get? We get the first equation, right? A plus b is equal to a plus b is equal to 2. You see? I use a different color what this case says us is that these lines overlaps. Yes, this line overlaps. They're the same line. So what it means? In other words, in the first case, we have a unique solution, right? Only one single point satisfying both equations at the same time. In the second case, we have no solution, empty set, sorry. So, meaning that lines do not intersect at any point at all. But in this case, lines intersect at all points through the real axis, right? Because these lines are continuous, meaning that they are defined at any point on the real axis in either direction, both in the x direction and y direction, in the positive or negative, doesn't matter. There is no point here that they don't intersect. You see, lines are the same, they overlap, which means that, so what will we conclude here? We conclude with a result that, and saying that actually there are infinitely many solutions here. In other words, set of real numbers has an infinite number of elements. So this third case says that it is possible to have an infinite number of solutions, as you see in this example. So this is the third case, right? Because points on these lines are infinite, right? There are infinite number of points on these lines, and they intersect at all points through the real axis. Okay, let's summarize what you have learned in this lecture before finishing. So actually, we now understand what a solution means for a given system of linear equations, right? And the solution is nothing but an n-tuple in the most general case, where we have n unknowns. But when we have two unknowns, as we use in our examples, we have two tuples that satisfies all the equations concurrently. Okay, when you plug the value that we assert that this is the solution, then it must satisfy both equations. This is what a solution means. And how many different possible ways for a solution of a given system? There are three alternative possible ways, as we all have seen. The first thing is the unique case, in the 2 by 2 case, where they intersect at a single point on the coordinate system. Another case, the second one, is that where we have no solution. In other words, the solution set is empty set, right? Where lines do not intersect at any point. And the third case is that where we have infinitely many points. In other words, the infinite solution case. And we see how we can interpret our solution from a geometric point of view. And we also understand what a linear system is, right? When the degree or the order of the unknown variables is 1, and this is called a linear system. When the order of any unknown variable is different than 1, then it's a non-linear system, but this is out of our scope in this course or in the next lectures. Alright guys, before diving into, as I mentioned in the beginning of this lecture, I tried to give you the sense that why we're trying to find what is a solution, how many different ways possible for a solution, can we interpret it from geometric points, what is a linear system means. Okay, I believe that we have answered all of these questions in this very first lecture before diving into the technical methods and matrix form in order to solve the system of linear equations by using advanced techniques such as Gaussian elimination, Gauss-Jordan or Cramer, and so on. Alright then, in the next lecture we will generalize this idea to an arbitrary number of equations and an unknown variables, where we have m equations and n unknown variables. In other words, when we have a n by n system, and start to understand how we can try to solve such a system based upon the simple idea that we just explored in this lecture. Alright then, see you in the next lecture, and until then, have fun.